Hello guys, my name is Saddam and in this video we are going to talk about derivatives, integrals and how to do plots of some functions. So we will learn about derivatives in a detail and as well as integrals. So let us start with derivatives. So I'm going to write derivatives here and we will first make it like style in terms of titles. So if you go to format and we will put on a style and we can choose whatever the style you want. Start with the derivative. I want to write how to find derivative. To find derivative, you have to write d parenthesis open and then sine. Okay, let's start with sine function and then here x. Let's say we want to. So what is the meaning of it? This means that we want to derivative. We want to differentiate sine of x in terms of x, like d sine x by x for first order derivative. Shift and enter, we got cos x. Now what we can do here, let's put x to the power n, and again the differential variable is x, so here it is nx to the power n minus 1. So that is the interesting thing. Similarly, what we can write here, that in general book, what we can see here, that y is equal to, it always written like this one, sine of x over cos of x. Okay, now if I'm writing this way, y is equal to 1 is equal to means that it is storing the value. Shift enter, it has stored the value. So the output is tan of x. Now I want to differentiate the y with respect to x. How we can do it? D y and then comma of x. That's all. Sec x square. Now one can ask that, okay fine, I need the derivative to, I need to derivate it 2 times, differentiate it 2 times. How we can do it? So let's say start with d of y, then again what we can do, you can write, you can use this parenthesis x. Now I want to differentiate 2 times here and then so on. Shift enter, we have 2 times. You can ask that, okay fine, I want to do it for 3 times, just put 3. I want to do the differentiation for 4 times, just put it here. So in this manner we can put as long as you want. Okay, so this is the very interesting thing. Now in another manner, what we can do here, let's first clear whatever the y we have. Let us clear y. Now let us have maybe some z is equal to sine of, let's say it is x, again cos of y. Okay, now y is maybe function of x, y can be function of x, and again we are choosing e to the power y of function of x. Okay, so this is my generally z. So z is this one. I want to derive derivative of z with respect to x. So this is the thing. Now for an example, if I don't say that y is not a function of x, what happens? Then for y, if I am not giving it that y is not a function of x, then it will consider that y, it will treat as some constant with respect to x. Therefore what will happen, that you will not see this equation, you will not see any kind of derivative. Okay, so here what you want to see here is just simple, y e to the power y cos e to the y into x, this one. So there is no any involvement of any derivative with this thing. Maybe it is your x square. It will give you a beautiful time. So that is 2x e to the power y. So this is the thing that is going to happen. So maybe we can make 2 times derivative. Okay, this one. So now I want to simplify that. Can we further simplify it? Yeah, full simplify we will use, and then percentage. What is the output number? That is 16. Then shift enter. So this is your full simplified. Beyond this, one cannot solve further. And again, what we can write here, that we can use traditional form, the way in books they have mentioned 16 and again maybe 17, the output number 17, and then this is the beautiful equation you can see here. So it has been written the way you are writing in your copy, or the way the books are written, the form. So to write in this form, we use traditional form. To simplify the equation, maybe you have more complex equation, you use full simplifying. Okay, to reduce, to make it the compact form. And to make it a double derivative, we use in this way, whatever the derivative variable is going there, and then the order of derivation is going there. So this is the way we do this derivatives. Now let's come to integrals. Okay, integrals, let's make it again another title, format, style, and then title, integrals. Then how to do integrals of some function. To find integrals of some function, we are going to use this command, integrate. Okay, integrate parenthesis open, sine of, let us say, x, and then 1x is going to go minus cos. So this is your indefinite integral. It has no any limits, that's why we are calling it indefinite integral. So whatever it is come minus cos x, so in your answers you will have to write always minus cos x plus c, some constant plus c. So that is the funda. Similarly, again we can write here integrate. Again, maybe you have this sine of let's say 2x squared. Okay, integrate with respect to x, what happens? So this is your equation. Maybe I want to integrate sine of x square. Okay, sine square x in terms of x. So the result is x by 2 minus 1 by 4 sine 2x. Now one may ask that, yeah, I want to do something like here sine square x, maybe what happens to sine cube x? This is your result. So in general, what can be possible that I want some general answer, then sine to the power sine x to the power m. So here it gives you the generalized result that if you put any function to it, maybe I am going to put some function to it, it will simply give me the result. How? Just take it here, copy it. Okay, I have copied it. Now what we can do here, that I am going to put this one slash dot. Now m is going to have, let's say, 1 minus cos x. So if I am having m to the power 1, which is sine of x, and then if I am going to integrate with respect to x, it will always give me minus cos x, just like here. So if I am putting here m goes to 2, so this we call a substitution method. Now if I am writing full simplify, so full simplify will give me this kind of function. Okay, so here it has some it has already a very beautiful thing, like for an example, if I am going to write here sine of square x, this one, x by 2 1 by 4 sine 2x. Okay, so if you will do this kind of thing, like for an example sine of x square, so it will again further simplify it. So I can write here full simplify. Okay, let's say full simplify. So full simplify will again do this kind of job, and you will end up with like minus cos of x, maybe here x by 2 minus 1 by 4 sine of 2x. Okay, similarly we can use m goes to 3. So this we call as substitution method. Substitution method will give you this one, let's say 4, this guy. We can again full simplify it, full simplify equation number 31. What happens? So this one. So very interesting result here. So this is the very beautiful equation. So this slash dot will allow you to substitute any value to this. For an example, I want to put, let's say x goes to maybe 2. What happens? This one. So whenever there is a x, it will come out as 2. Okay, so if I want to put x as well as m, so what we can do, you can use this parenthesis, and again m goes to 1. Okay, so what happens? Minus of cos 2. Maybe m goes to 2, what will happen? This guy. M goes to 3, so this one. So this is the way we do this. Now again, how can we put this integral sign? For an example, we do just like slash int. This is your integral sign. Okay, to put integral sign, we have to put escape button, ESC, whatever you can see here, escape button, escape here, and they can write int, integral, then click, sorry, slash int integral, and then here it is your integral. Now integral sign of x. Okay, space, again escape button, double D, and then escape button, d of x. It will give you minus of cos x. So escape it has already taken, so don't worry about it, minus cos of x. Similarly, I can write here integral, again sine of x, times cos of x to the power squared, and again escape button dd of x. So I am having this one. Maybe it is my 3, so it is my m. What will happen? Minus cos of x 1 plus m by m. So let us say maybe it has this value cos to the power n, and here it is. So if I am putting, let's say m goes to 1, I have this function. We can full simplify output number 43. So we have this beautiful equation here. Now you can put again what happens with your, if n goes to maybe 1. So this is the thing. CSC means cosec square x. So this is the very interesting thing. Now one can use plot. Okay, so how can we do these plot functions? Let us start with plots. Okay, now we have this plot and then again title. So maybe I have some function, let's say plot, to plot something. Start with sine of x. Okay, sine of x with respect to what? X. Now whenever you do plot, you specify some ranges. Okay, so we have this minimum range and again the maximum range maybe 10, and parenthesis close, and then this parenthesis close, and here boom. So this is your complete result. This is the output of this thing. Now again there are so many things. For example, we have this option theme. So theme is automatic. One can use web. You can see here this for web version. For minimal, this way. For detailed, this one. So whenever you publish in scientific article or wherever you do in books and so on, they use this kind of graph. Okay, maybe here we can use in marketing this way. For scientific purpose we use this way, or for classic we go with this thing. So let's start with some detailed function. So detail means that this, what does it represent? So for an example, we have used this plot function from this range and plot theme, that is called detailed. And now what else we can do? So let's click here and again label. We can label it. So how does the labeling work? For example, we choose this one and again size we are choosing, that is 12. Okay, now let's say we are choosing this bold to make it your axis this way. Now for an example, what can be your x-axis? X-axis we say, let's say auto. Okay, and then y-axis your maybe manufacturing. Manufacturing. Okay, let's click here, manufacturing and auto. What is your label? The label is auto versus menu. Let us see here, auto versus menu. Okay, this one. So you can see here manufacturing, auto versus manufacturing, and this way. Now the everything is there. What we can write here, that okay fine, put this one like theme. Okay, plot theme detailed, plot theme, what we can write, use here detailed. So the output number is 49. So what we can here write 49. So if I am writing 49, then it is showing me that auto versus menu sine x. But what happened? What happened to this labeling? Where does it goes? It goes because whenever you are using this everything, there comes with frame. So we have to put this framed. Okay. So for an example, we have to use again so many things to actually make it that what could be, and again so many things. So let us first plot different function. For an example, I would write plot x, and for x minus 5 to 5. Okay, minus 5 to 5 this way. Okay, now what we can again do here is simple. That is your theme. Again we can go to more. In more, what we can see here, that your plot style. So plot style gives you maybe some thickness, okay, opacity, everything you can change here. Now what could be the image size? Image size may be large, so this is your large. Maybe what could be your axis? Axis, maybe we can say that it is customary. Customary means xy, and then what could be the thickness, so we can make the thickness go away, this one, okay. So this is the very interesting thing here. So for an example, let's start with this problem, cos of x and so on. So this is the guy here. We can also change its color. Let's say plot style dashed, okay, then plot points 10. So here we have this 10 plots, okay. Now what else we can do? Plot, there are so many things. In plot in 3D, we cannot make it plot in 3D. Let us say maybe what we can use here, that may plot range full, whatever there is a plot range, we can again write it here. Maybe I can use cos square x. What happens now? This function, it is, what do you can use, thin or thick? So it is your thin, and again we can use thick. So there are a lot of things we can do here. Maybe I want to compare two graphs. For an example, here I have some one graph, and again maybe I want to put that what happens if I do this. I am going to do sine square x and again cos of x, okay. So in second bracket or in this parenthesis, we are going to write two functions which is having the same argument like x variable, which is changing in this way, and we are going to just write here. So this graph has this color and it has this whatever the function is there. So now you can simply change that. If I am changing some function, how this is actually changing its shape, okay. Now this shape is more or less same, but the difference is in phase. Now here is a shifting of some phase. So if you are in some physics class, or if you are in damping motion and so on, so there it is too much important to understand, to realize that how if we are choosing some functions and so on, how things are going to change. So I think for this introductory it is enough, and in later on we will talk about plotting some functions in 3D, or how there are different kind of plots. For an example, this parametric plots, stream plots and so on, vector plots and so on. So if you will do in your home, for an example, from help and Wolfram documentation, and you will just write here plot, okay, press enter, and you will learn more about the plots, that how we can deal all these things. So I hope this lecture is good for you, and if you like it, please hit a subscribe button.